I don't remember which part we have tackled. Have we seen this slide before? Tak ingat eh? No, rasa dah, tapi tak apa. Okay, so we have a vector here. Let's just call it A vector, and this is B vector. So how do I describe this vector? Okay, so let's say, Afika, can you please describe vector A? So vector A is 2 units, sebab ada 2, that 1, 2. And vector B is 5 units, right? So how would Afika describe this vector? Vector A is 2 units to the right. Remember, vector has magnitude and also direction. And so how do you describe vector B? Vector B is 5 units to the right.
B.
Is that right?
No.
Onward?
Vector.
Yep.
B is 4 units or 5 units?
1, 2, 3, 4. 4, sorry. Thank you. Okay, 4 units. Okay. So how do you describe this vector? What is the angle? I mean, what is the direction? Tak tahu kan? So usually they will say something, they will draw an x-axis for this vector, and the angle that the vector makes with the x-axis is the direction. So the convention is to always refer the vector with respect to the x-axis. Okay, another example is vector. So let's, okay, saya tak habis lagi ni, sorry. So this is 25 degrees. So B is 4 units and 25 degrees below the positive x-axis. Yes. Okay, so that's for B. What if we have another vector Q? Okay, Q vector, it has to have this half arrow. Q vector is 10 units. And how do I, okay, it has an angle of 35 over here. Okay. And I said to you, the convention is to describe the vector with respect to the x-axis, right? So how do I describe this vector? So let's say Q vector is 10 units. And what's the direction?
5 degrees.
What? Sorry?
55 degrees
Sorry.
above.
Sorry. 55 degrees.
55 degrees?
Above
Below the x-axis? Above the x-axis?
above the
Negative
Above the
x-axis.
negative x-axis. Yes, now it's complete. Now, if I just read this part, I can already imagine, oh, Q is 10 units and it's 55 degrees above the x-axis, which is also the same as 35 degrees with respect to the positive y-axis. It's the same thing, but the convention is to describe it with respect to the x-axis. Is that clear? Any questions?
No.
Tak ada, eh?
No.
Okay, next slide. Oh. So I think we already seen this slide juga, but it's okay. Okay, so the vector of magnitude 1 unit in a specific direction. So this guy, this vector A has 2 units. So it is written 2 small a with an arrow. So this just means the direction. My internet is unstable. Wow, that's me. Okay, so this means that the magnitude is 2, but the direction is A. So where is A? A is this way, given with this arrow. So R is this direction. How do I describe the vector capital R? Vector R is 4 units, okay? Therefore, 1, 2, 3, 4 in the direction of small r. So this is the direction. And this is the magnitude. Okay? So what if I want to describe a vector B? Whoop. My internet is, I don't know what's going on. Vector B is this way, and it is 3 units. So B vector, yep.
Adlina dia terkeluar sebab unstable network. Lepas tu dia tak dapat masuk balik.
Okay, kejap let me find out how to admit her again. Thanks. Oh, admit all. Kalau saya tak sedar, bagi tahu thanks. Because dia tak ada bunyi beep ke apa ke. Don't know. Okay, thank you so much for telling me. Okay, so B vector, how do we write this guy? So B vector is 3. Do I write the small b? Do I? Does anyone know? Nobody knows.
Yes.
Or do I write 3y like that?
No.
B, B.
B.
3B.
B.
Okay,
B.
did I mention anywhere in the question that B is this direction? Ada tak? Tak ada kan? But for this guy, I mentioned, oh, A is this direction, R is this direction. But for B, I didn't specify if small b was in that direction. So I can't say, oh, vector B is actually 3 in the direction of B. Sebab this small b is not defined yet. So unless I define it, so I should just describe it in general. So this guy is pointing in the Y direction, right? So 3 units in the Y direction. It's a positive, which means it's going up. If my B is like this, so this guy is minus 3Y. Okay, remember this just shows you the direction. For this case, the direction was given. To the right is A. To the whatever direction this is R. But for this guy, I didn't specify anything at all. So just in general, we just say B vector is 3 in the Y, in the positive Y direction. And this B is 3 in the negative Y direction. Macam tu. Okay. Any questions for this slide? Is everyone okay? No. Is the internet okay? Because I'm using Zoom. Zoom uses a lot more bandwidth than Google Meet. Okay tak? Start tak? Okay.
Okay.
Okay. Thank you. Okay, next one, equality of two vectors. Okay, this is easy peasy. It was covered in the video. So for two vectors to be equal, they have to have the same magnitude and also the same direction. So A and B is equal, are equal vectors. C has the same length as A and B, but the direction is different, so it is not equal. It's easy. Okay, straightforward. Okay, next one. Should I show my face? Would that help? Yep.
Ada seorang lagi tak dapat masuk.
Okay, thanks. Shit. Silap. Not supposed to open the chat. Sekejap tutup jap. Tutup jap. Participant. Yep. Admit. Okay, thank you. Tu je kan? Dah. Okay. Alright, so I'm sharing my face now. Don't sleep. Okay, you get to see my reactions. Macam lambat sangat kan? Okay, so negative vectors. So this vector is A. So I said, okay, please draw vector negative A. So please draw negative A vector. So it's just backwards, okay? And we have C in this direction. Please draw negative C vector. It's just the opposite direction, okay? It's easy. So negative vector is always opposite direction. Unless there's a number like 2a, then this one you have to multiply lah. So let's say a is 2 units. This is minus 4 in the direction of a. Yep, sorry. Okay, let's define. Oops. Okay, let's define the direction to this direction. Let's define a vector. Okay. A, small a. Small a is in that direction, and vector A, capital A, is 2 units in length. So I said, please draw 2a minus. Okay, so what does that give me? So if this is 2 units, now my A is 4 units. 1, 2, 3, 4. So that is 2a, but it's not negative yet. So this arrow is wrong. So the arrow should be this way. This guy is negative 2a. Okay. So that is, so the answer is minus 4a. So it's 4 units in the opposite direction as a, small a. Okay. Addition of vectors. So I told you that if the vector has the same direction, you can easily add it. Okay, easily add vectors in the same direction. Oh my God, got it right. So add components in the same direction. Okay, you can just add it directly. You don't have to resolve. But if you have vector A and vector B, where they don't belong in the same direction, you have to resolve, or you can use the geometrical method. Okay, what is the geometrical method? It was also covered in your video. So the addition of vectors can be done by geometric method, which is tip to tail or tail to tail. And there's also another method which is called algebraic method, triangle method, and the component method. The best one is always the component method because it deals with numbers. You can't ever go wrong with numbers unless you're not good with numbers. Tip to tail, you have to be really precise, really precise. If you are not precise enough, your resultant vector is wrong. Okay, meaning precise, meaning that you have to draw, if it's 2 centimeter, then 2 centimeter, then 3 centimeter, kena 3 centimeter, vector A, vector B, and then when you get a resultant, you measure it with a ruler. Okay, we're going to go over this next. Okay, so geometrical method, choose a scale. A scale means macam ratio lah. Let's say for 10 centimeter, you want to draw 1 centimeter. Okay, ni ratio tau, the scale. So kita buat meter lah. Dia confuse pula. So for 10 meter is 1 centimeter on paper. Okay, what you're going to draw is the centimeter guy. So let's say the length is 30 meter. So what you're going to draw on paper is just 3 centimeter. Okay, scale ni, once you use it, you have to apply for all vectors in the question. Okay, so we chosen a scale, 10 meter is equal to 1 centimeter. Draw the first vector with the appropriate length and in the direction specified with respect to the coordinate system. So let's say vector A is 100 meter. So converting this, I will get 10 centimeter on paper. So let's just pretend that this guy is 10 centimeter. And then vector B, this is A. And then vector B is it longer? Yep, it's longer. So let's say it's 150 meter. So converting this using the scale, it should be divided by 10. It should be 15 centimeter on paper. You don't have to write the on paper. I'm just writing this so that you don't get confused. So this guy, I'm going to draw 15 here. Okay. So the resultant force is from the origin to the end. And when I draw this line, the answer, the length is 20 centimeter on paper. Oops. Okay. 20 centimeter on paper, which means that the resultant force A plus B is actually, the actual value is 200 meter. Betul tak? Is everyone following me?
Yes.
Yes.
Yes? Confused tak? Pasal scale. Kita baru cakap pasal scale lah, kita tak start lagi. Any questions? Macam putus-putus lah korang sebenarnya. Saya yang putus-putus. Let me read the chat. If you have any questions, cuba write it down. Where's the chat? Chat.
Vector.
Yep.
Kenapa 200 meter?
Kenapa 200 meter? Scale dia, kalau saya dapat on paper 20 cm, so saya convert balik. So, because that's the actual value. Kan? Betul tak? Betul tak? Kenapa saya tak nak tutup ni? Gendutnya. Sekejap Dia lukis atas ni pula dah.
Maksudnya sekarang ni kita baru cerita tentang skill je lah kan?
Yes,
Belum
tak start
kira-kira
lagi. Belum start lagi
Okay.
scale tu.
Oh.
Baru cerita
Aku
pasal
macam
scale.
tengah kira-kira dah tahu.
Kena kira jugalah sebab scale. So how do I turn this off? Good job. Need to figure it out. Oh, sebab I tekan ni. Okay. Tak biasalah Zoom ni. Tutup ni. Okay, so kita baru discuss scale. So if on paper is 10 cm, it's equal to 100 meter in actual value. Kalau it's 15 here, maksudnya I'm actually drawing a vector that has a value of 150 meter. And if my resultant is 20 centimeter, the actual value that you should write, that you should give to me, the actual answer is 200 meter. The scale is for you when you are drawing sahaja. Okay, I hope that's clear. Now we will begin on the tip to tail thingy. Okay, let's padam jap. Ni cara renyah sikit lah sebab kena lukis, ada scale. But sometimes it's fun to just that I'm bad at drawing. Okay, so continuing. So your first vector, kita punya soalan is, what is the resultant vector of A vector plus V vector? Let's say that the resultant is denoted as R. Okay, so A plus B is just R. Okay, so starting with your first vector, your A vector is this way. This is your tail. Kenapa tail? Sebab belakang. Ekor kat belakang kan? Tail, that's your tail. Tip. Tip is at the front. And then the method is tip to tail. So this is the tip and this is the tail of vector B. This is the tip of vector A. This is the tail of vector B. So A and then you go with B. So tip to tail, draw your B. So this is where you end. This is where you start. The resultant is from start to end. Again, tail to tip, my first vector, and then my tail to tip B vector because it's A plus B, and the resultant is from the start to the end. Okay, what if I have more than two vectors? Where should I draw this? Okay, let's draw it here. Okay, let's use a different color. Okay, so let's say we have vector A plus a vector B plus a vector C is my resultant vector R, right? So let's just copy this one A is this way, and then we have B this way. Remember, tip to tail. So this is my tail, this is my tip, and then tip to tail of B, then tip. So another vector C, let's just say it's this direction. Again, this is the tip of B to the tail of C. How should I write my resultant? Can anyone answer me? Can anyone try?
Is it A vector plus B vector plus C vector, doctor?
Yes. I mean, how should I draw it? The resultant of this guy.
The tail of the resultant could connect to the tip of the C vector.
A to N.
Huh?
A to C. A to
A
C.
to C.
Ya, daripada hujung A tu bertemu hujung C.
Ya, betul.
Ya, hujung,
Ah.
betul. Tapi hujung mana?
Start tail A. Start
Tail
from
A.
the origin from to the tip of C.
Okay, betul. Okay, so it's from the origin to the end. Remember? Origin or the start from to the end. Kita panggil start or origin eh. So, like that. That is your resultant. But if you are adding, it should go from tip to tail, tip to tail, tip to tail, and then resultant from the origin to the end. It's different. Okay, it's no longer tip to tail. Is that clear?
Yes.
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 Okay, so that is okay. So this is another example: A, B, C, D. So this is tip to tail, tip to tail, tip to tail, tip to tail, and the resultant is from the origin or the starting point to the end. Because you started with A, you ended with D. Okay, so this is your resultant. Okay. So let's say, sekejap, kita cantik pula. Let's say I want you to discuss pula. I want you to describe I want you to describe vector D. So I have this angle over here, which is 100 degrees. How do I describe vector D? Okay, lupa nak bagi length. Length of T is 5 centimeters. Can anyone describe to me D, vector D? Okay, nak carilah participant. Can I get...
Doctor,
Yeah. Apa?
is it like A plus B plus B plus C plus C plus D? Dia macam asing-asing. So macam contoh A plus B, lepas tu B plus C, we cancel out the B in the middle.
We can buang B in the middle.
Oh, Faiz punya vektor tu vektor max form 5
So macam last kali you buat
Lain.
panjang mana pun kalau daripada A, kalau last tu D just A to D je.
Oh, itu macam displacement kan?
Macam displacement.
To displacement. Untuk vector dia lain sikit lah. But you have to bear with me, nanti kita akan belajar displacement. We will get to know how different it is. Dia ada, for now kena belajar macam ni dulu. Okay? Boleh tak? Tapi displacement tu betul. Is that okay?
Alright.
Okay.
Okay. Thank you, doctor.
Okay. Okay, so how to describe a vector D is, nak suruh siapa? Nak suruh Anis Hanini. Are you there?
Yes, I'm here.
Okay, can you please describe vector D for me? I already given you the length and the angle.
Vector D is 5 centimeter, 80 degrees above negative x-axis.
Okay, betul.
Is it right?
Yes, betul.
Thank
If you
you.
want to describe in positive x-axis pun boleh. Okay, so either one point is correct. Okay, just checking. So that was okay. Thank you. So tadi tip to tail. Now it's tail to tail drawing. So you have two vectors again. Sorry, that was bad. Okay, let's focus on writing this properly. Okay, A vector plus B vector. Tadi it was tip to tail, now it's tail to tail. So tail of A meets with the tail of B. How do I get the resultant? I draw a line that is parallel to vector B. It doesn't necessarily have to end at that point, so I just go up until I like. And then I draw another line that is parallel to vector A on top of B. So it intersects there. That is where my resultant ends. This is my origin, always origin to endpoint. So this is my resultant. Okay, so for the tail to tail drawing, it's nice if you have two vectors, but it's a little bit difficult if you have 3 or more. Okay, so this is fairly straightforward if you have two vectors. So is this method clear? Kita dah go over tip to tail and tail to tail. And again, use the scale factor to convert the length to the actual magnitude. Okay. Triangle method, I'm going to skip that. I'm not going to use it. Okay, so special case of vector addition. Let's just take a look at this first. How do we add A and B? So B is given as, so don't look at that answer first. Let's say they give you A this direction and B that direction. You can still use the geometrical method to find your answer. But for minus, it's just you draw it first, tip to tail. So tip to tail, to tip to tail. And then this is your B, right? But your B is negative direction. So patah balik. Okay, so this guy needs to go. It should be the same length, but opposite direction. Okay, I think this is okay. This is easy. It's just the opposite direction. And then from the origin, let's use a different color. From the origin to the end, that is your resultant, which is A vector minus B vector. Okay. Tak adalah special sangat, senang je kan? Okay. Oh, what's this? Okay, kena padam. Penatlah padam. Can I just duplicate this? Will it duplicate everything? Give me a minute. If you have any questions, you can ask me now. No questions?
Doctor, in the exam, will we be allowed to choose which way we want to use, which method we want to use to solve to like find the resultant vector?
Okay, so for specifically chapter 1, you don't get to choose. Usually use the geometrical method to solve for this question. Contoh for chapter 1. Use the component method to solve for this question. But for other chapters, you can choose whatever method that you like or find most comfortable. But it's always the case, you will always use component. Macam memang akan pakai component method. Because that's the one yang pakai calculation. So sebab kita kan, okay, saya tak cerita exam lagi kan. Our exam is, contohnya soalan 1. Let me write it. So let's say we have 5 questions kan. So question 1 will be chapter 1. Question 2 will be chapter 2. Sebab each question is the entire chapter. So one question ada banyak anak like A, B, C, D, but it will all be on chapter 1. Sorry for the bad handwriting. And chapter 2 pun sama, ada banyak anak A, B, C, D, but everything is chapter 2. So for question 1, which is on chapter 1, you don't get to choose if you want to use geometrical or component. The question will specify it for you. But other chapters, just use component. That's the easiest and most precise way of doing things. If you insist on using geometrical, boleh, but itulah kalau tersilap lukis, habislah silap. Okay, is that clear? Okay.
Thank you, Doctor.
Okay. Okay, so let's just go over this one quickly and then we'll take a 5-minute break, okay? So this is vector A. I can resolve. Okay, how do I start this one? Okay, let's just vector A and I can resolve it into the X component and Y component. Okay, just bear with me first. I'm going to write this. Okay, this is a vector B, resolving it in the X component, which is in the same direction as the X axis, and resolving it in the Y direction, which gives me BY. Okay, so for this guy, I can resolve it as well. So I resolve it like this. This is C. Susah tau bagi tablet ni. I'm not used to it. Okay. Cuba lukis betul-betul. Okay, so this is vector D. So in the X direction, I will get dx component. And in the Y direction, I will get dy component. Now the question is, how do I resolve? For me to resolve this, I need to know the angle. And so dx is d cosine theta and dy is d sine theta. And I believe some of you dah tanya, why is it dy is a sine, why is dx is a cosine? Okay, let's go over that. So now let's take a look at a triangle. Our x component is in this direction. Let's just call it adjacent kan? And this guy is our y direction. Let's call it opposite. And your vector is your hypotenuse. Okay, so your vector D is your hypotenuse. So how do I find dx or d in the adjacent? I know my d hypotenuse is 10 meter. My angle is 25. Contoh So sine theta, let's just write it down. Sine theta is opposite over adjacent. And cosine theta is adjacent over hypotenuse. Sorry, this is not adjacent, it's hypotenuse. Why didn't anyone correct me? Are you guys sleeping? Don't sleep yet. I'm going to give you a break. Okay, adjacent over hypotenuse. Then tangent is opposite over adjacent. Can. Okay. Opposite, I told you opposite is actually dy because that's in the y direction, and adjacent is dx, right? So kita potong kejap, tulis dy over d. And this guy is, opposite betul. Adjacent is dx over d. Potong kejap. Opposite is dy over dx. Okay, is everyone following me so far? Benda kacang tu kan? Is everyone okay? Okay.
Yes.
Now we go to the finale. Okay, taklah finale sangat. So we want to solve for dy. How do I rearrange this equation? dy is d sine theta. That's how you get the sine. Dx is d cosine theta. And theta is inverse tangent of, opposite is dy over dx. So that is how you get your equations. Okay tak? Okay tak? Pening?
Okay, doctor.
Okay. One last equation. How, if I have dy value, let's say 5, and dx value, let's say 3 centimeter, how do I find d using the Pythagoras theorem? Using Pythagoras theorem, guys, come on. It's easy peasy lemon squeezy.
4.
Pythagoras theorem. So it's 5 squared plus
5
3
squared.
squared equals to
4.
d squared, right?
So, yep, d squared.
So d is 5 squared plus 3 squared, square root the whole thing.
And then there's
If
like a
I were
huge square.
to generalize, if I were to generalize this equation, my 5 is actually dy, right? And my 3 is actually dx. So square root the whole
Okay.
thing gives you the magnitude of d. So 1 equation, 2 equation, 3 equation, number 4 equation. So the theta gives you your direction. Provided that you know what dy and dx is, you also get to know your magnitude. If the question gives you vector d, asks you to resolve it, use the sine and the cosine. If they give you dy and dx, they ask you to find d, use the Pythagoras theorem equation and also the theta equation, which is inverse tangent of dy over dx. Okay, let's take a 5-minute break. Let's come back after 5 minutes around 2:50. Let's just 3. At 3, let's come back at 3. Please take a break. I'm going to come back at 3, okay? Don't turn it off, just mute or something.
Doktor,
Yeah. Baru nak mute.
jawapan ni dalam perpuluhan ke?
Jawapan dia boleh dalam perpuluhan. It can be in decimal points.
Oh, okay. Thank you. Berapa decimal point, Doktor?
Always 2. For exam, always 2. Yep.
Alright, thank you.
Okay, come back at 3. Talk soon.
Doktor,
Yep,
nak tanya boleh?
boleh.
Ya, dia memang dah tetap yang sin tu untuk cari value of y, cos for x
Tak,
and tan for theta.
tak. Nanti kita akan bincang kenapa tak.
Okay.
Ni untuk general je, general when your theta is here, basically vector untuk vector type ni je, dx, dy ni. Dx is a d cosine and dy is a d sine. Nanti kita tengok pas ni. Is everyone back? Cuma nak tahu semua orang dah back ke rumah. Susahnya. Is this your last class?
Yeah, for today.
Yay. This is also my last class. Okay, is everyone okay? Ngantuk kan? Tapi saya dah kasih break kan? So kena fokus lepas ni. Okay, I'm gonna start now. So tadi, siapa yang tanya tadi? Ridwan Was it?
Yes, saya.
Okay, Ridwan asked, is dx always, does dx always use the equation d cosine theta? And does dy always use the equation d sine theta? The answer is no, not necessarily. It depends on where your theta is. So let's talk about that. Okay, so is it this example? Let's just make a new example. Okay, so this one laid out as blank. Okay, so let's talk about a few situations where the equation is different. Okay, let me draw the example just now. So this is my axis and my vector is this little dude called B, and Bx is this way because it's in the x direction, and By is this way. My theta is here, so my Bx is B cosine theta, and my By is B sine theta. Now, what if my vector is not in the first quadrant, but in the third or the fourth or the second? What happens then? So let's say our vector is here, okay? And my angle is given over, let's use the green one. My angle is given here. First, let's say it's 15 lah. Okay, so that's a second example. Let's draw another one. This guy over here. Sorry lah, sangat bengek. Learning to adjust with this tablet. Here. And your angle is in green. This theta is here. Let's say it's 20 and this vector is called T. Apa lagi situation? One more. Okay. Hope I have enough space. This vector is the same as B, but it has angle over here, which is 50. Okay, so let's start. Oh, tersilap warna, tak apalah. This is vector E. Okay, so for vector C, I want to resolve my vector. What should I do? My vector should always be in between my components. That's the first point. My vector or my resultant should be, how do I spell should? Okay, boleh tu should be in between components. Okay, for example, Tadi I said bx is here and by is here. My b vector or my resultant vector is in between bx and by. So if my resultant vector here is here, my bx and my by should be over here. Alamak, warna sama. Let's use green. My by should be here. Sorry, cy. And my b.
Doktor ada orang tak masuk lagi.
Ada orang apa? Tak dapat
Tak
masuk?
masuk lagi.
Oh, okay. Kejap. Participants. Tak ada buat? Oh, dia tak masuk lagi as in macam mana tu? Toilet? Oh, okay, ada dah.
Doktor, Aiman Afika tak masuk.
Tengah approve ni. Approve. Lagi tak yang tak masuk? 36 in meeting. I'm missing one more, I think. Because kita ada 37 orang kan? Itu 38. Okay. So I'm gonna assume orang lain tak ada nak masuk dah But ada yang sharing kan? Okay. So I said, okay, Aiman Afika, I said my vector or resultant should always be in between components. And we have seen this for the first example, whereby my vector B or my resultant B is in between Bx and By. So if this is the case for C, so my Cy should be here and here, right? So my Cy is going in the positive y direction, and my Cx component or my x component for C is going in the negative x direction. Okay, what about D? My D should be in between the components. So it should be here and here. So this is my dy component. It is going in the negative y direction. And this is my dx component, which is going in the negative x direction. And this guy, this is my ex, and this is my ey. Remember, your vector should always be in between components. Kalau your E is this way, takkanlah tiba-tiba kita punya EY kat sini kan? Like, why? Why are you here? Don't do that, okay? It should always be in between, Allah. It should always be in between your components. Okay, so that's the first step. Second step, where is your angle? Your angle is touching, theta is touching CX. This guy, theta is touching DY. So this guy, theta is touching EY. Okay, the second rule. The component that touches, gonna try to write this nicely. The angle, Allah, macam mana tu pula dah H dia. The angle theta, it will have the cosine in the equation. Cosine in the equation. Okay, equation EQ je lah, susah tulis. Okay, so let's do this one. The component that is touching the angle here is CX, right? So my CX is C cosine theta. My CY is C sine theta. See, CY doesn't touch the angle, so it's a sine. For this guy over here, the angle touches the Y component. So my dy is D cosine theta. My dx is D sine theta because my dx does not touch the angle. Okay, so third example, EY touches the angle, so it's E cosine theta, and EX is E sine theta. Okay, so here you should be careful. sometimes when you put in the value 15 and so on, your CX value should be a negative. But sometimes the answer gives you a positive. So daripada situ, you have to use logic and say, okay, CX should always be a negative. Maybe the angle, maybe it should be referring from here for it to be a negative and so on. Okay, my point here, apa benda ni cakap ni? My point here is that you have to look at the diagram and see which direction it is going. So CX is obviously a negative, kan? Okay, kita buat dalam kurungan lah. CX is obviously a negative. This guy is obviously a positive. D cosine theta is, sorry, the dy is negative. Dx is negative. EY is positive. And your EX is positive. So if your answer, when you plug in the numbers, it's a negative, maksudnya ada something wrong lah kat situ. Okay, so you always use your logic to backtrack your calculation. Okay, so now the question is, kenapa angle yang touching component jadi cosine? Okay, so you have 2 points. You have 2 things that you need to remember here. The question is, why is the component touching the angle gets to be a cosine? Does anyone have the answer for that? Ada nak try tak? Trying. No tries? Salah pun tak
Doctor,
apa. Yep.
This is my guess lah. Because that component is the line adjacent to the angle.
Betul? You are correct. Betul. Thank you. Who was that? Saya tak sempat tengok.
Oh, sorry.
Hah? Who was that yang bagi tahu tadi?
Am I supposed to say my name, doctor? Or
Yeah.
video or I am Balvinda.
Oh, okay, Belvinda. Okay. Thank you. Thank you, Belvinda. Okay.
Yeah, welcome, doctor.
So, betul. Belvinda is correct because it is adjacent to the angle. Okay, let's see. Let's draw this in a triangle form. Let's use, okay, ni senang sangat. Let's use D vector, okay? Let's draw this in a triangle form. Tilt your head. I'm going to draw it like this. So imagine that, macam nak cakap, this triangle, kita flip dia rupa macam ni. Just flipping it so that you can see it clearly. Okay, it's the same triangle, tau. Okay, so dy is this direction. Tahu tak? Okay, I'm just flipping it. So this is D. So I should use the same color. Okay, let's use the same color lah to make you guys see better. Okay, so D vector is a pink. Itulah pakai lagi banyak color kan susah. Okay, so D here. Okay, and then this is our dy. Okay, let me use red for dx, okay? Dx is here, okay? I'm just flipping this diagram. So dx, okay, kita buat dy dulu. Because dy is this way. That is my dy. And my angle is here, right? And then my dx is, because I'm flipping it, it is actually here. Okay, but I want to draw a triangle, so it is tip to tail, right? Tip to tail. Vector ni tak bersambung pula dah. Kejap. Okay. Right. So use my pink again. Remember, Allah. Forgive your lecturer. Okay, D. This is dy. And the red one is dx. Tak nampak sangat, but this is dx, okay? Again, I just flip the diagram so that you can see it clearly. I still have dy, kemudian I have this theta, and then I have the d vector, and then dx, instead of putting it here, I'm drawing it here, macam parallelogram punya method tu so that I get a triangle. Tip to tail, D, vector is my resultant. Okay, so remember that we have a sine and cosine. Sekejap, siapa yang texting ni tu? Oh, tak ada. Okay. Remember that we have sine and cosine. And I ask you to define what is cosine, what is sine. Let's write it again in hopes that it is gonna be clear for everyone. Okay, siapa yang dah pandai tu, tak apa, please bear with me. Okay. Okay, so let's use this green. So remember sine theta is apa? Sine, opposite over hypotenuse. Cosine is theta adjacent over hypotenuse. Here the adjacent for this triangle is actually dy. So that adjacent and this guy is the opposite and this guy is the hypotenuse. So how does this equation become? Sine theta becomes, so opposite is dx, h is d. Solving for dx gives me d sine theta. Boleh dx sine theta. And then for this guy, sama juga, adjacent is dy. So this becomes dy is equal to h is d cosine theta. Lama tak nampak. Cosine. Okay. So again, it depends on where your angle is situated. Okay, so I've given you an easy way to remember this. The component that touches the angle will have the cosine in the equation. So here, the angle touches the dy, so the dy gets the cosine. So here, we get the cosine. Okay, so that's just a way to remember it. You can also draw this triangle, no problem at all, but it's going to take some time. Is that clear?
Clear.
Clear ke? Okay.
Clear.
Clear, Doctor.
Alright.
Clear, man.
Okay. Penat tau. Spelling. Okay. So vector components. It is useful to use rectangular components, as I said before. These are the projections of the vector along the x and the y axis. So ax and ay, kita dah belajar how to resolve it just now. The magnitude is ax squared plus ay squared will give you the magnitude of a. Only the magnitude, not the direction. The direction is given by inverse tangent, the ay component over the ax component. Okay. Easy peasy lemon squeezy, it's just an equation. And remember the theta that touches the component gets the cosine. The component that touches the angle gets the cosine. Okay. So yang ni kita dah belajar dah, kita terlebih advance. So that's fine. Okay. Okay, ni pun dah. So this is valid only if theta is measured with respect to the x-axis. As I mentioned before, if your angle is here instead, it is measured with respect to the y-axis. So equation ni dah tak valid. So remember the component that touches the angle gets the cosine. So this equation does not apply when your angle is not measured with respect to the x-axis. Okay. Okay, we already covered this one as well. Okay, so that was 2D vectors. What if we have 3D vectors? We will have the components. So this is in the x direction, this is in the y direction, this is in the k direction. So instead of a equals to ax plus ay, you will have ax plus ay plus az, and pray to God that you don't have to deal with this vector. Tapi tak adalah, dalam exam tak ada 3D. So you're going to be fine. 2D is simple. Okay, this one. Okay, let's talk about this one. Okay. I told you before we discussed dalam slide, in the previous slide, kejap tengok balik slide tu. Okay, this one. This equation is valid only if theta is measured with respect to the x-axis. Meaning to say, the conventional way to do this is always, the theta should always be with respect to the x-axis, right? Okay, so let's take a look at this one. So you should already know how to resolve A and B. It's easy. Given that you have the angle. Okay, so angle kat sini pun boleh. Theta 1, this is theta 2. Theta 1, theta 2, doesn't matter. You know how to do it already. What if they give you C vector like this and they ask, okay, so C vector is given, resolve C into its components Cx and components Cy. And for this guy, resolve it to dx and dy. How should you do it? Can anyone guess? No takers?
Repeat balik.
Soalan balik Okay. So we have a vector C that is going in the y. Sorry, I need to focus when I draw this. That is going in the y, positive y direction. So this is your vector C. The question is, resolve this vector in its x and y components. What is your calculation step? Do you know the angle to this guy? Do you know the angle of C?
Doctor,
Yep.
so do we take theta to be 90 degrees?
Yes, correct. Always measure with respect to the x-axis. That is the conventional way to do it. So with respect to the x-axis, vector C is 90 degrees, right? So Cx is C cosine 90 and Cy is C sine 90. What does this give us? Cosine 90 is what? Is it 1 or 0? Cosine 90, 0.
Zero.
So the x component, the x component of vector C is 0. And the y component of vector C is C. So this guy only has a component in the y direction. Does that make sense?
Yes.
Okay.
Yes,
What
doctor.
about D? Can I ask someone from the list? Kejap Let's see. Can I get Mashita, please? Alamak, Mason terkeluar. Can I get Mashita to answer for D? Can you please resolve D in its X and Y components?
Doctor, can you hear me?
Kena kuat sikit suara.
Wait. Okay. For dx, to find it, d cos
D cosine. Berapa angle dia? With respect to the x-axis, angle dia? Is it 10?
0.
Zero. Yes, betul. You're not wrong. So cosine 0 is how much?
Equal to 1.
Yeah, so dx is just d. What about dy?
Dy is d sine 90 degree.
90?
Degree.
Mana datang 90?
Wait.
The angle should always be the same, right?
Zero juga.
It is still sine 0.
Yes, okay. So again, remember, that's a good mistake to have. Now we all know that the angle for both of these guys has to be the same, Like the above, both of them were 90. Yang membezakan dia, the cosine and the sine. Okay, so sine 0 is a 0, is it? I think so. Okay, so it's a 0. So there is no y component for the d, and the dx component is equal to d. Okay, thank you. Okay, was that clear for everyone? Did that make sense? Any questions for me? Haris ada soalan? No questions? Don't know where to see the chat.
Doctor,
Yeah.
when we solve this question, do we always take it with respect to x, the x-axis?
Solving, yes. Unless
Okay, thank you, Doctor.
angle that is with respect to y, then usually from x-axis. Okay.
Okay, thank
Welcome. Okay. Addition using component method is next. So addition using component method. Component method is resolving, right? So for A vector, we resolve it in the AX and AY. And then for the B, we resolve it in the X direction and the Y direction. And then you add the X components together and the Y components together. I mentioned to you before, you can only add vectors if they are in the same direction. So that is why we need to resolve, because to add A and B, the direction should be the same, and the direction yang sama is AX dengan BX, and direction AY sama dengan direction BY. So you will get RX here and RY here. So RX is AX plus BX, RY is AY plus BY, and the magnitude for the resultant force is using this equation, Rx squared plus Ry squared. The modulus of this guy is the magnitude and the direction is this guy. We already discussed this. Okay. So addition using component method, what you should do is resolve it first and then tambah. You add the x's together, you add the y's together, and then you get the Rx, the Ry, and then baru you proceed to this step. Okay, so first resolve. Number 2, add components with same direction only. Kalau X dengan Y tak boleh tambah. Wrong. Components with the same direction only. Once you have the Rx or the resultant X and the resultant Y, you find the magnitude and the theta of R. Okay. It's pretty simple, but you need to remember the steps. Okay, resolve all vectors. Okay, ini dah buat dah. Rx, Cx, Bx, Cx, Dx. Ni kalau, if this is the situation when we have more than 2 vectors, just now we had 2 vectors again. Yep. This one is if we have more than 2 vectors, same thing, resolve it, Ax, Bx, Dx, and then add them together. Ay, add with By, add with Cy. Dy doesn't have a component, so it's just a 0 there. Okay. Use the Pythagoras theorem to find the magnitude of the resulting R. We already know this one. And then problem solving strategy. Read and understand the question, visualize and sketch the vector diagram. Remember, the vector should always be in between the components. And if you are drawing the triangle, tail to tail diagram is the most favorable. Tail to tail is this guy, A vector, B vector, resultant is always in between the components or in between these two vectors. Choose a suitable 2D rectangular axis, resolve all vectors into chosen axis if you need to resolve at component by component. Okay, so just x with x's, y with y's, z's with z's. Okay, dah repetitive. Addition of vectors will get you resultant displacement. So ni contoh je, physics examples. Addition of vectors will get you resultant displacement, net force or resultant force, electric field at a point. We will see the displacement thingy in questions later. Net force, we will look into this in chapter berapa? I think chapter 3. And electric field next semester. Subtraction of vectors next semester. Okay, 2D components. Motion in horizontal plane. East, west, north, south axis. Okay, so I had a question from someone. I think it was from K13 code. Okay, please take a look at page 9 in your module book. Okay, is everyone following me? Do you have your books with you? This part?
Yes.
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 Okay.
Page
So
berapa ni?
page 9. Okay, so someone tried to do this question, PBL 1.3, and the answer says, the answer is 245.5 kilometer north of west, 68.55 degrees north of west. And they asked me, what is north of west, doctor? Okay, let's discuss this part. So we have north going upwards, right? And this guy is east. And this guy is west. And this guy is south. So north of west means, okay lah, kita tulis dulu north of west. South of east. What else? West of north. What does it mean? What is the direction? Okay, so I'm gonna put this bracket dekat off west, off east, off north. Okay, let's take a look. The first one, north of west. So off west. So I'm going in the west direction and north. I'm going in the west direction, but I want to go north as well. So this is how, kalau kita lah dengan dia kan, nak pergi west tapi nak pergi north juga. So jadilah lengkungan macam ni. But for the resultant, it is actually like this. That is what it means. West, but you're going north. Okay. So that's your first example. So south of east. So I'm going south, but I also want to go east. So I'm going this way. That's your number 2. This is your number 1. I'm going south. I'm going east. Kita refer to the one in the kurungan first. We're going east, but we're also going south. So like that. And then we are going north, but we want to go west. So it's here. We want to go north, but we want to go west. So it's the same place as number 1. That is your number 3 as well. So off is your reference point. Okay, your reference point of west, but you want to go north. So your reference point goes north. It's like that. South of east, your reference point is east, going east, but going down, south. So it's this way. And then west of north, your point of reference is north, going upwards to the west. So it's this way. Okay, I hope that's clear. Okay, so ada kat sini, the slide says motion in horizontal plane, east, west, north, south axis. I don't think you will have a problem if you understand my example. Motion in vertical plane, vertical and horizontal axis. Okay, ni 2D je. Motion on inclined plane. Okay, this is going to be a little bit confusing, but we will tackle this as well. Circular motion, lambat lagi belajar. Forces on rigid body, lambat lagi belajar. These two are like killers, but not to worry. And then 3D components, motion in space. That's an example. We will motion in space. Ada code sikit. Okay, but not to worry. As long as you understand the steps that we discussed, should be fine. Okay, so let's do an example. The figure shows three forces, A, B, and C. Remember, force is a vector. Force is a vector, which means that it has magnitude. It also has direction. Each magnitudes of 120 Newton, 96 Newton, and 150 Newton respectively. So that means this A is 120 Newton. Let me use right. B is 96 Newton and C is 150. Okay, I'm gonna take 7-minute break because sakit tekak. Please take a look at this question. Try to solve it yourself first. Okay, 10 minutes lah, lama sikit. I'm gonna ask one of you guys to give me the answer and how to do it. Okay, is 10 minutes okay? Or you need more time?
Okay.
10 minutes or 15? Remember, I'm going to ask one of you randomly. 10. 10 minutes is okay.
20.
20? No. It's either 10 or 15. 15 lah. Then kita discuss. Okay, please start now. Try to do it yourself. Calculate the resultant force. Remember, you can do tip to tail or you can resolve it. You can ask me if you want. Tapi I'm not going to give you the straight answer lah. You can ask for tips. Okay, please. Hello, welcome back. Who is my lucky volunteer? Ataupun yang kena paksa? Sekejap. Siapa yang macam rajin? Can I get rajin terpaksa? Can I get mana tadi? Hakim Zamani. Hakim Zamani, are you there? Earth to Hakim.
Yes.
Okay, can you
I'm
read
here.
to me your answer? Macam mana you buat? I'll write it down.
My answer for the resultant force is 54.13 Newton.
Sekejap. 50, berapa? 54?
Yes.
54.13
Newton.
Newton. Can you tell me the equations for you to get that answer?
First of all, cari x axis punya total number and then cari y axis satu-satu.
Cari
So
total
untuk x axis untuk A,
okay.
120 cos 28 equal to 105.95
95, correct. Lepas tu
Newton. Okay, so untuk y axis dia 120 sin 28 equal to 56.34
okay, good.
Newton. So cari untuk B pula. So kalau untuk B 96 cos 56 equal to 53.68. Tapi since dia ke belah kiri, so dia jadi negatif.
Yes, good. Okay.
So untuk B, untuk Y, 96 sin 56, 79.59.
Okay, thank you. Okay, C.
Untuk C punya x-axis equal to 0. Untuk CY, negatif 150 sebab dia ke bawah.
Yes, correct.
So, X component tambah dengan X component, Y component tambah dengan Y component. So, untuk X component total dia adalah 52.27 Newton. So, untuk Y component sama dengan negatif 14.07.
Okay. What about the magnitude? Yep.
Lepas tu magnitude dia 52.27 kuasa 2 tambah dengan negatif 0.7 kuasa 2 and then square root.
Kuasa 2, okay. 14.07 square root is squared and then
square root dapat jawapan 54.13 Newton.
13 Newton. The direction?
Untuk the direction, saya guna tan negatif 1 dalam kurungan yang 14.07.
Okay.
Bahagi dengan 52.27 and the answer is 15.07.
So you don't have to use the negative here?
Yes, kena guna, tapi saya guna negatif tu untuk tentukan dia kat kuadran berapa. So kalau dia kat kuadran 4. So kalau untuk dia kat kuadran 4, so dia adalah sekejap. Dia adalah east of south.
East of south. East of south. So east of south, I'm going east of south. So it's like that. Macam tu ke?
Yes.
Okay, let's see. Your Rx, kita tengok So your Rx is positive, it's this way. Your Ry is negative, so it's this way. Your resultant should be in between these components, right? And your angle that you've got is 15.07 below the positive x-axis. Yes, correct. South of east.
Yeah.
South of east, right? Or below positive x-axis. Okay, thank you so much, Hakim. I think that's all for today. Any questions for me or any questions for Hakim? Did everyone get the same answer? I did not calculate this. Sama tak jawapan korang? Ya, semua buat tak? Ya.
Tiba-tiba sama.
Tiba sama, okay. Huh? Yep.
Doktor,
Yeah.
macam mana tahu dia kuadran 4?
Macam mana tahu dia kuadran 4? Okay, so tadi kan Hakim said he added all the x components together and all the y components together, right? And the addition of ax, which is this guy, with this guy gives us a positive value, dapat rx. And then the addition of ay, which is a positive value, and the by, which is a positive value, and cy is a negative. Total y component is negative. So, kalau kita nak lukis Rx dengan Ry on a different axis, I'm just going to draw a new one. Rx is positive 52.27. So, it's this way. Sepanjang 42.27 Newton. And Ry is negative 14 going down. Sorry, it's 14.07 going down or negative 14.7. Okay, so it's slightly shorter than the Rx component. So the resultant is, remember the parallelogram thingy? Is this, tak betul. It should be going towards the, it's hard to draw. Kejap. Give me some time. Where is it? Okay. Why is it going towards the, okay, it should be closer to the x-axis because kita, remember we can draw a parallelogram. Ni kalau nak ikut logik lah. Drawing something parallel to the Rx and drawing a line that is parallel to the Ry. Finding the intersection gives us the resultant, and finding the angle of the resultant is there lah. So the question, why is it in the fourth quadrant? Because it's positive Rx and negative Ry. It depends on these values. Let's take a look at another example. If my Rx is negative 10 Newton and my Ry is 20 Newton, which quadrant should my resultant be? Okay, let's see. Okay, I am having problems with writing straight lines. Sekejap, I can't see. Okay, got it. Tak adalah sangat. Okay. So Rx is negative, right? Negative going to the left. Rx to the left. Ry is a positive going upwards. So now can you guess which quadrant it is in? It is
Quadrant 2. Quadrant 2. Yeah, quadrant 2.
So that is how you decide. You decide on the value. Second. What? Okay. So how do you know the angle if it's below the x-axis or above the x-axis? How do you know? For tadi, we know that the angle is below the x-axis. What about this guy? This guy over here, the one that I just drew. How do you know if it's above or below?
Punya result kat
Kena lukis. If you draw it, you can see it. Okay, whether it's above or below. So always try to draw it. Don't try to imagine it, just draw it. Okay, that's my tip for today. Always draw. Okay, any other questions? Before we end our class? I need to check.
Doktor.
Yeah.
Miss,
Yes, what's the question? Tak dengar.
sorry. Instead of writing like north of east or south of west, can we just write northeast and northwest?
Boleh juga.
Like no need to mention off. Okay, thank you.
Boleh? The of to because it was in the answer. So I just wanted to explain that part. Okay, so north of west was, yep. Yes.
When the equation ask about the resultant force, mesti always ada answer modulus R dengan theta tu
Yes, always, because we always want the magnitude, we always want the direction because it is a vector. Always. So kena ingatlah equation tu. Other questions? We have 5 minutes. Is everyone okay?
Yes. Okay.
Okay, that's good. Okay, if you have any questions, feel free to WhatsApp me. Sometimes I'm busy, so I reply a little late, but believe me, I try my best to reply. If I can't reply to your WhatsApp, hopefully I'll answer it in class, okay? So if I don't reply to you, please just remind me. I won't, tak adalah terasa ke apa, just tell me, okay? Because sometimes I forget. Okay, that's all for today. Hope you guys have a great rest of the day. Don't forget to eat. I will see you on Thursday. Kan? Thursday kan? Is it? Yeah.
Yes.
Okay, bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, boss.
Welcome.
Thank you, Doctor.
Bye.
Thank you, doctor.
Thank you, Doctor.
Thank you.
Bye.
Bye.
Bye, Doctor.